So today we're just going to do a little bit more than we did yesterday, and you're going to see a new direction, and that's something you want to make a note of, is that when you see this new direction, it's going to tell you that you need to do something extra than we didn't do yesterday. Okay, so I'm putting that up front right now. So let's take a look at what we already know. Oopsie. From our unit circle stuff yesterday and prior, not just yesterday, but we have to find, let's say, the sine of x squared equals -1. They're asking for where does the rise equal -1, right? So if we know our unit circle really well, we can locate this fairly easily and just say, well, x equals -1 at that particular radian, which is 3 pi over 2. Right? And that was your homework, right? Going through yesterday, and you practice that. Sometimes there's one answer, sometimes there's 4 answers. It could be many answers, 3 answers. It just depends, right? But we were staying true to the idea that looking for the angles that were somewhere on this circle, but more specifically, only between 0 and 2 pi, including 0 as an answer. However, there's actually more answers to this question, right? And we looked at this a little bit when we were doing the wrapping, right? And here's what I'm talking about, is that if we look a little closer, if we kind of tie some different things together here, right, we'll have our -1, but we'll also have, right here, our 0, -1, which is 3 over 2. But you might remember one of the questions on the quiz and your homework was, give 3 different lengths that match this angle. And you had to come up with 1, 2, or 3 different lengths. And some people say, well, yeah, this is 3 pi over 2. And some said, oh, it's -pi over 2. That was another one. And then another one on top of that was maybe all the way around, right? And you do a whole nother circle. So you add 2 pi to this, and that's also the same circle. Same radian. So turns out that we can go round and round and round here to a bunch of the same answers just by going around 2 pi, another 2 pi, that's also the same if I add another 2 pi on top of it. Also, I can go the other way. I can go -2 pi, that's also an answer. So all of these are actual answers, and we can come up with a way of writing it in a very simple form by saying this. Well, if I add 2 pi to this, right, since that's the distance to the next solutions, meaning if I start at 3 pi over 2 and I go 2 pi, well, that's another solution. If I go another 2 pi, that's another solution. So if I add 2 pi to it, right, I actually get another answer, right, that also has a sign equal to -1. So if I go around 1 time, that's plus 2 pi. But then we do a little trick where we say 2 pi n, and this is going to be the number of rotations. So by adding this little part on the end of our specific answer, it's now called a general solution. So I want you to equate this part with this part. If you see general solution, that means you need to have this here. If the directions say just 0 to 2 pi, then you only need the first part like you did yesterday. So reading the directions is going to be key, right? If you put it on everything, it's not correct. If you don't put it at all, it's not correct. You need to have it there when you need it and not have it there when you don't need it. So the directions will tell you what to do. Okay? So what this does right here is this n says, well, no matter how many, n can be 5, n can be 1,000,000, right? If I go around 1,000,000 times, well, that still has a sign of -1. N can be negative, so if I go clockwise, 500,000 times, that angle also has a sign of -1. So by just having this n here, it takes care of no matter how many times you go clockwise or counterclockwise, it's also an answer, right? So it's a way of somewhat describing an infinite number of answers. No matter how many times you go around, right, it's another answer. This also has a sign of -1. Go around again, that one also does. Go, 1,000 times clockwise, that also has a sign of -1. All of them do, right? So that's what that little plus 2 pi n does for our answer. Okay, it takes care of the infinite number of possibilities that we possibly could have. All right, and that's really the only part you need to think about. The n is always going to be there in every solution. However, the distance to your next solution, how this is 2 pi, this can change. So if I had another, let's say I had a point up here that was also answers, because some of your problems last night had 2 answers, 3 answers. Well, now the distance between one answer to the next is only pi. So this will change depending on how far apart your answers are from each other. Okay, so that's what we'll look at today and practice a little bit more right now, and then you'll have plenty of time to get started on this in class right now. So let's look at something like this, very similar to yesterday. We have sine squared x plus cosine 2x equals 1. So you might need your formula sheet if you don't have it memorized yet. What would be a good substitution for cosine of 2x, given that we have a sine squared? And which one would you use? There's 3 of them. Which one would you use? Give that a think for a minute. Cool. All right. And you would come up with probably what? Yeah.
1 minus 2 sine squared.
1 plus 1 minus 2 sine squared, which you can get off your formula sheet. And you chose that because
There's already sine squared.
keep them all the same, right? So keep them all the same. Good idea. Let's do a little simplifying. We got a plus 1 on both sides, so that'll cancel out when we subtract 1 on both sides. And then we have 1 sine squared x minus 2 sine squared x, which equals just negative sine squared x. And if we divide both sides by -1, we'll have sine squared x. So in a sense, the negative just drops off since we divide 0 divided by -1. All right, and then we need sine, right? So we have to do one more step and take the square root of both sides. So now we have sine of x equals 0. And where does that happen? Where does sine of x equal 0? All right. So we have answers. Where is the rise equal to 0? Right here and right here. Okay. So as I mentioned earlier, you see how these are not 2 pi apart, like up here where it had to go all the way around, 2 pi. But on this one, it's only pi apart. All right, so my answer, how I want to write this, I still want to write the general solution, or the 0 to pi solution first. So start at 0, which is right here. And then you're going to add in the distance apart from the next solution, right, to the next solution, to the next solution. You always have to go another pi. So I'm going to add pi, and then I'm going to have the n that's always there, which signifies going around an infinite number of times. Right. Now, since we do have 0 here, we can technically drop it and just say x equals pi n as our final answer. And it can be positive and it can be negative. It just has to be an integer, and it can go around and around. And this describes, all the answers that are all any multiple of pi, basically. You take any integer, multiply by pi, that's a solution. So let's go ahead and try it here. Why don't you guys try number 1? Give that a shot. See if you can get that. All right. Yeah. So based upon your homework last night, this is what you got up to, and then you had just your answers separate. Notice how there's an overlap of both of them having 3 pi over 2, so we only, even though there's 3 answers here, there's only 2 of them on the graph. And once again, they're pi apart from each other, right? Pi apart. So this time, we're gonna start at pi over 2. Now, you could say, well, can we just start at 3 pi over 2 and then add pi? Let's just do as a convention, and we all decide to do the same way. Choose the closest one to 0. So of these two, if we're going around in the positive direction, pi over 2 is before 3 pi over 2. So we're going to say x equals pi over 2. So the next solution is going to be pi, and we can do that forever, as many times as we want going around, n times, no matter where n just could be any number, as long as it's an integer. So that would be our final answer there. Okay. All right, so your homework is on the next page. It's a worksheet that will show you work on another piece of paper, but I want to get the first one started with you. So if you want to grab a piece of paper real fast and we can start this off together. So let's look at number 1, which is sine of 6 no, 6 times sine of x plus 5 equals 2. So we can, let's get sine by itself. We'll subtract 5 on both sides, divide both sides by 6. So first subtract 5. Negative 3 on the right. Divide by 6. Negative 3 divided by 6 is negative 1/2. And then find out, well, x must equal what? So the height is 1/2. What's the reference angle? 30 degrees, so will be divided by 6 for each one. And it's negative. So where is sine negative? 3 and 4. So quadrant 3, 30-degree reference angle is 7 pi over 6. Quadrant 4, 11 pi over 6. And hopefully this is getting a little more automatic, and as you're doing your homework, you didn't maybe have to use your unit circle as much, if not at all. Like you're gradually making progress towards our next test on Friday next week, that you don't need the unit circle. You have it pretty much, you know, memorized by heart. All right, let's look at this, graph it. So we're looking at right here and right here. Now you'll notice on this one that the distance from one solution to the next is not the same, right? It's not 90 degrees or 180 degrees. So the distance from here to here, right? If I choose this as my value to rotate, where is it? You know, like this was, oh, there we go. Yeah, if I chose this blue value, like these are all the same distance. So it has to be the same distance from here to here as is from here to here, right? But we don't have that on this problem, right? So what do? What's the strategy when we don't have that? Okay? All we have to do is write basically 2 separate statements. So we'll have to write a statement for 7 pi over 6. So x is we're going to have 7 pi over 6. And then from here, ignore this other one for now. To have all the possibilities of all the multiples of 7 pi over 6, we'd add 2 pi. Because to get back to it, you have to go all the way around. Or reverse, right? 2 pi n. And then we write another statement for the 11 pi over 6. And also, to get back to it is also 2 pi. So on this one, we do have to write 2 statements because 11 pi, there you go. Because these are not equally spaced. From here to here is not the same as here all the way around. So I can't just add one number and keep on getting to a new solution. And so we have x is going to equal both of these, like so. So it's nice when we can write one statement. It's just not always the case. So that's how, I think those are enough examples to kind of get you going. And you get to practice using your trig identity formulas, and then below using a little review. Like I said, we do have a test coming up, so for the review, see how much, of course, you can do on your own and how comfortable you are with it. And if you need to, practice until it becomes more familiar and a little bit easier to get through. All right, so you got a little bit of time to work. You're just doing this, just the worksheet that's in your notes on a separate piece of paper, and that will be it.